So let's get that same matrix into R. Okay, it was that matrix -4, 2, -1, -1. Okay, and so I'm going to get I'm going to store all the eigen stuff in something called eigni, like so. And if I type that, I'll see that I get the eigenvalues and the eigenvectors. And these are exactly what I computed by hand, much quicker. These are the eigenvectors, the column vectors. Here's eigenvector number 1. This one corresponds to this eigenvalue. This eigenvector corresponds to this eigenvalue. Notice that these are not exactly the same, numbers that we got when we computed the eigenvectors. But remember, what we said was that the eigenvectors that we got spanned the space, spanned the eigenspace for these corresponding eigenvalues. So this is in fact in the span of 1, 1. Okay, this vector lies along the line that makes a 45-degree angle with the x-axis. And also, if you take a look at this eigenvector, it's also in the span of the other one, which was 2, 1. So in fact, this number here is twice this number. So that checks out perfectly, right? Let's now, what if I do A times say eigenvectors, the first one, okay? Then what I should expect to see is that what I'm going to do is I'm taking A and then multiplying against this vector, and what that should do in fact is turn this thing around, change the signs to all positive, and lengthen it by a factor of 3. And so in fact, if I do that, I see that's exactly the case. Okay, it's exactly the case. This number, 2.68 whatever, is -3 times this. So this vector is yeah. Now remember, for that other eigenvector, and when we were looking at that, actually our first eigenvalue that we found was -2. Remember, for that one we said that we could actually we should be able to hit this corresponding eigenvector 2 times, and it'll swing it back around and effectively multiply it by a factor of 4. So I should be able to see that if I take A squared and then multiply, right, because I'm squaring that matrix A by EIG vectors second column. Okay, whoops, S2. Okay. Yeah, so I'm taking this second eigenvector here, and I'm going to multiply it twice by the matrix A, which should, okay, it should be essentially like multiplying this vector by -2 2 times. Okay, so if I do that, well, that's not correct at all. What happened there? Here's the problem. It's right here. Got A raised to the power of 2. A raised to the power of 2 looks like this, which is actually A times A this way. It's doing element-wise multiplication. Okay, it's not the same as a regular matrix multiplication. So what I need to do is maybe I'll write a little function. Turns out you can write your own functions in R, and I'm going to make a function called %. This is just sort of makes sense, right? I want to write a function where I can use the caret symbol to raise a matrix to a power in the usual way that we would raise a matrix to a power. It's a function of a matrix and some number n, and so if n is equal to 1, then return the value of A. Otherwise, do all this stuff. You can read through that, should make some sense. And so now, in fact, if I do A %, A, I should get actually something different, right? Whoops, that's not at all right. meant like this. There we go. Okay, so now maybe if I try that again and do a squared this way, then I get good. That makes sense now, because if I just look at eigenvectors, right, that eigenvector there, and multiply by -2 raised to the 2th, right, times that. Now this should be okay, right? I should be able to do this because this is a scalar and this is a vector. I don't need the percents this time, okay? And I get exactly the same thing.